Algebra 2 final review. Question number 1. Classify negative 3x to the fifth minus 2x cubed by the degree and the number of terms. Well, the highest degree is 5, so that's a quintic. And there are 2 terms, so it's a binomial. So number 1's a quintic binomial. Number 2. Negative 7x to the fifth minus 6x to the fourth plus 4x cubed by the degree and number of terms. Well, the highest degree is fifth, so again, it's going to be quintic. How many terms are there? There's 1, 2, 3 terms, trinomial. Answer is B. Number 3, write the polynomial in standard form. Well, we can divide every term by 3. So it's going to be 2x squared minus 3x cubed plus 1. But it says specifically standard form, so we have to write it from greatest to least. So it's going to be negative 3x cubed, and when I mean greatest to least, I mean by the power, plus 2x squared plus 1. So the correct answer is negative 3x cubed plus 2x squared plus 1. So the answer is A. B has the right terms, but not the correct order. Number 4. Write the expression as a polynomial in standard form. First number squared, so it's going to be x squared plus 2x minus 24. You can FOIL that however you want. You're going to get x squared plus 2x minus 24. If you don't know how to do it the shortcut way, just do it the long way. X times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x. And 6 times negative 4 is negative 24. Sum like terms, you get that answer. So the answer is C. Write 4x cubed plus 8x squared minus 96x in factor form. Okay, let's look for a GCF. What's the greatest common factor amongst all the terms? It looks like I can factor out a 4x. If I do, what am I left with? X squared plus 2x minus is that a 24? Okay, I need to find 2 terms that have a product of negative 24 and a sum of positive 2. Well, I get 6 and negative 4. So my answer should be 4x times x minus 4 times x plus 6. Answer is B. Okay, number 6. Write a polynomial function in standard form with zeros at 5, negative 4, and 1. Well, we had a theorem that gave us some rules about zeros. The rules were, for every 0 I'm giving, I have a binomial that says x minus that number. So I got x minus 5 with a product of x minus negative 4. And a product of x minus 1. And I just got to distribute. So I really have x minus 4 times x plus, sorry, x minus 5 times x plus 4 times x minus 1. So worry about x minus 1 just a second. So x minus 5 times x plus 4 is going to be x squared minus x minus 20. You can work that out. Now we're going to multiply by x minus 1. So, to make it a little easier, I'm going to move the x minus 1 over here. Okay. So now let's just distribute. X times x squared is x cubed x times negative x is negative x squared, and x times negative 20 is negative 20x. Now go to the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative x is positive x. And negative 1 times negative 20 is positive 20. I'm going to sum like terms, so I'm going to get x cubed minus 2x squared minus 19x plus 20. So the answer is B. Okay. Number 7. Find the zeros and state the multiplicity. Well, what would make x plus 3 equals 0? Remember, negative back over front, so that'd be negative 3. That would be 5. So negative 3 and 5 are my zeros. But how many? How many negative 3's do I have? Well, it's squared, so I would have 2. How many 5's would I have? Well, it's to the 6th power, so I'd have 6. So I'm looking for negative 3 with the multiplicity of 2 and 5 with the multiplicity of 6. Answer C. Number 8. Divide 3x cubed minus 3x squared minus 4x plus 3 by x plus 3. Couple ways we're going to do this one, okay? I'm going to use synthetic division. So what's the root of x plus 3? Negative 3. Okay, now all I have to do, if we're doing synthetic division, is write down the coefficients in order. Make sure no coefficients are missing here. So I've got 3, negative 3, the next term's negative 4, and the last one's 3. With synthetic division, here's what we do. We drop the first term, 3. We're going to multiply the root by 3. We get negative 9. We're going to put that number right there, negative 9. We're going to add these two terms together, the negative 3, negative 12, or negative 3, negative 9, to get negative 12. We're going to multiply negative 3 by negative 12, and we're going to get 36. 36 plus negative 4 is 32. Okay. Negative 3 times 32 is negative 96. 3 plus negative 96 is negative 93. That is going to be our remainder. So we'd rewrite this as 3x squared minus 12x plus 32 with the remainder of negative 93. Answer is B. Now, if you want to do division, long division, we can. Okay. You write it like this. X plus 3 on the outside over 3x cubed minus 3x squared minus 4x plus 3. Okay, we've got to make this number always match this number completely. So what do we need to multiply the whole term by? Well, we need to multiply it all by 3x squared. So what I'm going to do over here, so I'm going to write 3x squared times that. So it's going to become 3x cubed plus 9x squared. Now we're going to subtract them. So our first term should always become 0. My next term becomes negative 12x squared, and we're going to drop the next one, minus 4x. So what do I need to multiply x to make it negative 12x squared? I need to multiply it by negative 12x. Okay. So I'm going to need to multiply negative 12x by x plus 3. So negative 12x times x is negative 12x squared. Negative 12x times 3 is negative 36x. We're going to have to change the signs. We're subtracting them again, so that becomes a plus and a plus. That's a 0. This becomes positive 32x. Now, what do I, and we're going to drop the last term, plus 3. What do I need to multiply x by to make it 32x? Well, I need to multiply it by positive 32. So when I multiply 32 times x plus 3, I get 32x plus 96. Again, I'm going to subtract them. First term 0, and I get negative 93. Okay, since that was my last term, that is my remainder. So I get the exact same answer either way. It's really up to you on what you see and how you feel. So I'd have my remainder of 93. Either way, the answer is B. Number 9. 6x equals x, 9 plus x squared. Set it equal to 0, make it a quadratic. So 0 equals x squared minus 6x plus 9. All I did was I subtracted the 6x over. Okay? And I just put it in order. Okay, now we've got a quadratic. Two numbers, product of 9, sum of negative 6. Well, this looks like a perfect square trinomial. So negative 3 times negative 3 would give me 9, and the sum of that would be negative 6. So 0 equals x minus 3 times x minus 3. So the root of each of these would be x equals 3. Only possible answer, 9, is A. X cubed plus 216. Okay, remember what the easiest way to remember this one is x cubed plus c cubed has a specific pattern. It's going to go x plus c times x squared minus cx plus c squared. So we got to find the cube root of 216 to do this thing. Well, I see a 3 will go into that 72 times. 72, since we have a 3, let's stick with it. 3, 24 times. 24 would be 3 times 8. And 8 would be 2 and 4. And 4 would be 2 and 2. So I got 3 3s and 3 2s. So that's the same thing as the cube root of 3 cubed times 2 cubed, which is the same thing as 3 times 2, which is 6. So the cube root of 216 is 6. So my c value is 6. So it would be x plus 6 times x squared minus 6x plus 36. Answer is B. Alright, and since it's multiple choice, here's the tricky way to do it. Here's a fast way. This term times this term should equal this term. So it's a negative and a positive, so that wouldn't work. Negative and a positive, that wouldn't work. 6 times 72 is way bigger than that. So by elimination and just looking at the last numbers, you could have got B. Number 11. C cubed minus 512. Well, this is going to follow, well, since it's C cubed minus, it doesn't matter what we do, A cubed has this value. It's going to be C minus A times C squared plus CA plus a squared. So it looks like 8 is going to be the cube root. We could use our shortcut. The negative number times this number has to be negative 512. So that's negative 512. That is not negative 512. That is not negative 512. This is negative 512, but it has a negative sign out there, doesn't it? So let's erase all this. If we remember the equation, so by elimination, just multiplying the last numbers, we already found the answer is B. But which one meets the criteria? Okay, C times 8, C minus 8, C squared plus 8C. Yep. Easy enough. Number 12. X to the fourth minus 20x squared plus 64. So we could treat this just like a quadratic, but instead of using x, we'd use x squared. So we could say this is x squared. Let's do our x factor. I'm skipping on you guys. Two numbers that have a product of 64 and a sum of negative 20. Probably negative 4 and negative 16. Okay. So again, because that's to the fourth and that's squared, we can treat it just like a quadratic. So we could rewrite this as x squared minus 4 times x squared minus 16. Well, both of these happen to be what? Differences of squares, don't they? So we could rewrite the first one as x minus 2 times x plus 2, x minus 4 times x plus 4. Now, be careful. Don't get fooled on that one, because that's not a difference of squares. That's not right either. There is a solution. So, we found the difference of squares, and C is our answer. All right, next problem. Okay, number 13. Solve 125x cubed plus 343 equals 0. So let's look. So this is really going to be 5x cubed plus, what is the cube root of 343? 7. 7 cubed equals 0. So we could rewrite this as, if you remember, 5x plus 7 times 5x squared, so that'd be 25x squared, minus our a times c value, which would be minus 35x plus our last value squared, so plus, dang it, 49. And that's what we got thus far. Okay. So we got one answer right now off the bat that's pretty easy to see as I'm erasing everything else. Okay, so we know one root right now is x is going to equal negative back, negative 7 over 5. So we have a solution. Okay, we know a couple of things. Number one, we're going to have 3 solutions because we have 3 roots. So negative 7/5 is one of them. Now all we've got to do is solve this. And you're like, oh my goodness, Coach Allen, that looks really hard. No, just plug it in the quadratic. So the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be 35 plus or minus, and all this junk's going to be over 50, by the way, plus or minus the square root of b squared, whatever 35 squared is. Luckily we have a calculator. 35 squared, 1225 minus 4ac. Our A value is 25. Our C value is 49. Okay, so that's going to be 35 plus or minus the square root of 1225 minus 4900 all over 50. Alright, so let's do some work. What is 1225 minus 4900? Negative 3675. So 35 plus or minus the square root of negative 3675 all over 50. Okay, so right now we can look and just tell our answer is going to have to be A, because we've already found one of our roots. But let's say we don't see that. Okay, we've got a prime factor, the square root of 3675. So let's work on that. First thing we're going to do is the square root, I'm going to do it over here, the square root of negative 3675 is equal to I times the square root of 3675. Okay, 3675. So let's prime factor that. So I know 25 is going to go into that, right? So 25 is going to go into 36 one time. And then I'm going to have 1117, so that's going to go in 4 times. Then I'm going to have 175. That's going to 7 times. Okay, 147. 25 is just going to be 5 and 5. We're done on that side. 147. Well, that's going to be a 7 and a 21. 21 is going to prime factor to 7 and a 3. So the square root of that can be rewritten as the square root of 5 squared, 7 squared, and 3, which is going to be 35 square root of 3. Okay. So now I have 35 plus or minus I, or it's 35I I should say, 35I square root of 3 all over 50. They didn't factor it any further, but there you go. 35 plus or minus 35I square root of 3 over 50. So again, the answer is A. Hopefully this makes sense. Again, you could have solved it pretty quick once you found one of them, knowing you need 3 answers. Okay, number 14. Solve x to the 4th minus 34x squared equals negative 225. Okay, step 1. We're going to treat it like a quadratic because we can, because it's x to the 4th and x squared. So it's important we see that. So let's rewrite it. X to the 4th minus 34x squared. We're going to add 225 to each side, so we can set it equal to 0. Okay, now we can x factor it if you don't see it right away. Two numbers that have a product of positive 225 and a sum of negative 34. Two negative numbers. Negative 9 and negative 25 happen to fit the bill. So we're going to get x squared minus 9 times x squared minus 25 equal 0. What do we notice? Those are difference of squares, so we can rewrite this as x minus 3 times x plus 3. And then x minus 5 times x plus 5 all equals 0. Which this should kind of make sense. We have a 4th degree polynomial, so we should have 4 answers. My x is going to be 3, negative 3, 5, and negative 5. Those are all my solutions, remember, with the roots of everything. So plus or minus 3, plus or minus 5. Answer C. Number 15. Okay, Use the rational root theorem to list all the possible rational roots of the polynomial equation of x cubed plus x squared minus 7x minus 4. It says do not find the roots, it's just find all the possible roots. Well, it's going to be all the factors of negative 4 over 1. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4. So we should have 6 answers. Answer's A. Find the roots of the polynomial. 2x cubed plus 2x squared minus 19x plus 20. Okay, this one could be a tough one if we forget something. We know if there's a rational root, it's going to be 20 over 2. So it's going to be all the possible factors of 10. Or sorry, 20 over 2. So what are all the factors of 20 over 2? So there's a lot of choices here. So you could be 1, 20, 2, 10, 4, 5. All that's plus or minus, plus or minus 2 on the bottom of it. Okay? So there's a lot of choices here. We could have went with plus or minus, I'm just going to put the thing around it, of 1/2, of 1, of 2, of 4, 5 halves, 5, 10, and 20. Luckily, it's a multiple choice test, so I see 4 as a possible rational root and negative 4. So once we find one of those to work, we can move on forward. So let's try 4. I'm going to use synthetic division with the 4 and see what we get. And again, hopefully this will work. So the first coefficient's 2, the second coefficient's 2, the third is negative 19, and the fourth is 20. Synthetic division, drop the first term. 4 times 2 is 8. Add those, I get 10. So we're at 40. Okay. We're going to be at negative 21. So 4 is not going to work for us. So we can cancel 4. Now we can try negative 4. So drop the 2. 2 times negative 4 is negative 8. 2 plus negative 8 is negative 6. Negative 6 times negative 4 is 24. Negative 19 plus 24 is positive 5. 5 times negative 4 is negative 20. So there we go. So negative 4 is a root. So we can mark out B and D. Okay, so now we just got to go from there. So this, since we factored out a negative 4, we can rewrite this equation as 2. Now instead of a cube root, it's instead of a third degree, it's going to be a second degree. So it's going to be 2x squared minus 6x plus 5. We can say that equals 0. We can just go ahead and jump straight into our quadratic. Okay, so our quadratic was negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's what we got. What's our b value? Negative 6, so it's going to be negative negative 6, so it's going to be positive 6 plus or minus the square root of negative 6 squared, so 36 minus 4ac. So that would be 4 times 10, which would be 40, all over 2a. Well, our a value is 2, so that would be all over 4. Okay, so I can rewrite this as 6 plus or minus the square root of negative 4 over 4, which could be 6 plus or minus 2i over 4, which can be simplified. We can factor out a 2. 3 plus or minus I over 2. So I'm looking for 3 plus or minus I over 2. Answer's A. 17. A polynomial equation with rational coefficients has roots of 5 plus the square root of 1 and 4 minus the square root of 7. So our rational root theorem, so the rational coefficient root said I'd have to have the conjugate. So if I have 5 plus the square root of 1, I'd have 5 minus the square root of 1. If I have 4 minus the square root of 7, I'd have 4 plus the square root of 7. So I should have 4 plus the square root of 7 and 5 minus the square root of 1, which is 4, by the way. The answer is B. 18. Find a third-degree polynomial equation with rational coefficients that has roots of -5 and 6 plus I. So I know, again, because of my roots, I can write x minus -5 times x minus 6 plus I times x minus 6 minus I. Because remember, if I have a root that's 6 plus I, I must have a root that's 6 minus I as well. So those are my 3 roots. So now I'm just going to distribute these. So I get x plus 5 times x minus 6 minus I times x minus 6 plus I. See what I did? I distributed the -1. Okay, so let's multiply the far right together. See what we get. So x times x is x squared. X times -6, -6x. X times I is xi. Okay, we're done with the first term. Go to the next one, -6. -6 times x is -6x. -6 times -6, positive 36. -6 times I is -6i. Okay. Now go to the last one, -i. So -i times x is -xi. -i times -6 is positive 6i. And -i times I is -i squared. Okay. Now let's simplify our terms where we can. Okay, I have a positive xi and negative xi, a positive 6i and negative 6i. Okay, negative I squared, well, I squared becomes what? -1, so -1 becomes +1. So I get x squared minus 12x plus 37 times x plus 5. Almost there. Okay, we could actually take a shortcut here. What's 5 times 37? 185. The answer is going to be A. Let's go ahead and work it. X times x squared is x cubed. X times -12x is -12x squared. X times 37 is 37x. Go to the next term. 5 times x squared is 5x squared. 5 times -12x is -60x. And 5 times 37 is 185. Sum the terms, what do we get? X cubed minus 7x squared minus 23x plus 185. My answer is A. 19. For the equation 2x to the 4th minus 5x cubed plus 10, find the number of complex roots possible and the number of real roots. Okay, so let's look. I've got a 4th degree polynomial. So total, I'm going to have 4 complex roots. I have to. And remember, if I have 4 roots total, I could have real, or we could say imaginary, right? So I always have to have even numbers of imaginary. So real, if I have 0 imaginary, I could have 4 real. If I had 2 imaginary, I'd have 2 real. And if I had 4 imaginary, I'd have 0 real. So 0, 2, or 4 real roots. Answer is A. Number 20, for the equation, find the number of complex roots, the possible number of real roots, and the possible number of rational roots. Okay, rational. Find the number of complex roots. What's the highest degree? 7. So 7 complex. Okay. The real roots are going to be odds this time. So I could have 7, 5, 3, or 1. And what are the possible rational roots? Well, the possible rational roots are pretty simple. They've got to be all the possible factors of 5. So it would be plus or minus 5 over 1. So plus or minus 5 or plus or minus 1. So the answer is A. (21) Find all the zeros. So we've got 2x to the fourth minus 5x cubed plus 53x squared minus 125x plus 75. Okay, so luckily for us, we've got some solutions to kind of work backwards from. Otherwise, we would have to find all the possible rational roots between 75 and 2, which would have been a ton. So, since I have 2 negative signs, 2 positive signs, we're going to start with a positive small number. Let's start with positive 1. So since we have a 1 there, we'll try that one. So let's use synthetic division. So my terms would be 2, negative 5, 53, negative 125, and 75. So let's make sure we do our work properly. Drop my first term, 2. 2 times 1 is 2. Do the difference here. I don't know if we're going to get big enough fast enough. Let's see. Negative 5 plus 2 is negative 3. Negative 3 times 1 is negative 3. So that's 50. That's 50. Actually, wow, it's going to work. Negative 75. Negative 75, 0. So 1 works. Thank goodness. Alright, so now we know the answers are going to be between B and C. So, since we know 3 halves is another number, let's try 3 halves with it. Okay, so now we're going to use this set for 3 halves. This better work because it's an answer in both. So you drop the 2. 2 times 3 halves is what? 3. Negative 3 plus 3 is 0. 0 times 3 halves 0. So the 50 drops. Excellent. 50 times 3 halves is positive 75. So the negative 75, positive 75 drop. So that works as well. So now I've got 2x squared plus 0x, if you need to see that, plus 50. So I could rewrite this as 2x squared. I don't know what just happened there. And rewrite it as 2x squared plus 50 equals 0. Okay, subtract or divide everything by 2. Actually, let's do this. Make it 2x squared equals negative 50. Solve for x, divide each side by 2. So x squared equals negative 25. So x is the square root of negative 25, which is going to be plus or minus 5i. So my answer should be B. Again, so the key is use the answers to find the rational roots. 22. In how many different orders can you line up 8 cards on a shelf? So since we're using all 8 cards, it's basically 8 exclamation point, right? Which means 8 times 7 times 6 times 5 times 4. So we're going to put 8 in our calculator. On this calculator, go to the math function. I'm going to use my probability. And I'm going to use number 4 on this. So 8 exclamation point for me. Enter. Great, I cleared it. 8 math. Let's see if I can do it quicker this time. Probability, hit the 4, hit enter. 4320. My answer is D. Okay, easy enough. I know this was a long one. We got a lot in here. 23. Evaluate the expression. Okay, that was easy enough. Go 5 and use our exclamation point again if you need to. Enter. It's 120. Answer is B. These are give me's. Okay, 10 exclamation point over 3 exclamation point. Okay, let's see what that's going to look like. What this is saying, basically 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Okay, so you can see you're going to get a really big number pretty quick, because you can say this is 20 times 42 times 72 times 10. And if you want to do the math, it could be 720 times 840. And you're going to get really big numbers really fast. Okay, I'm just doing it by hand. 4 times 0 is 0. 4 times 2 is 8. 4 times 7 is 28. So we're going 0, 0, 0. Next number is 16. 7, 5, 0, 0, 8, 4, 0, 6. Not very good handwriting. Answer is A. You can still do it in your handy dandy calculator just like we did before. 10 exclamation point divided by 3 exclamation point is 604,800. So I want to kind of give you an idea of what it actually looks like. All right, permutations. 9 permutation 4. Okay, what this is saying, the easiest way to do it is we're going to start with 9 and we're going to go with 4 terms. So a permutation is going to be 9 times 8 times 7 times, we're going to stop at 6 because it's 4 terms. Okay, and again, calculator work would make this 72 times, so 42, 72 times 42. So you know you're going to end with something in a 4. So I got 144, 0, 8, 28. So 4, 2, 0, 3. And again, calculator work, you can just plug it in. It is 3024 either way. Hopefully that's easy enough. Answer is D. 26. All right. 7 combination 6. So basically, it's saying we're going to go this many terms up top. So combination looks like this. We're going to have 7 terms on top. 7, okay, times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. So the answer should be 7. So let's do that on our handy dandy calculator really quick. So I've got 7 combination 6 equals 7. All right, next one. The Booster Club sells meals at a game. Each meal comes with a choice of hamburgers, pizza, hot dogs, cheeseburgers, or tacos. So our entree is 1, 2, 3, 4, 5. So we get 5 entrees. And a choice of root beer, lemonade, milk, coffee, tea, or cola. So 1, 2, 3, 4, 5, 6 beverages. So how many different combinations? You just multiply them. 5 times 6. Answer is 30, so D. 28. Determine the probability of getting 4 heads when tossing a coin 4 times. Well, what's the probability of getting a head 1 time? 1/2. How many times do we have to do it in a row? 4. Alright, so you can think of it like that. So that would be 2, 4, 8, 16, 1/16. Or you could do 1/2 to the 4th power. Let's get the handy dandy calculator out. 0.5 to the 4th power. 0.0625. Answer is D. Alright, that concludes the first part of the Algebra 1 review.